Let us discuss higher order ordinary differential equations. This is the fourth session of higher order ordinary differential equation, in which we are going to discuss particular integral for the right hand side is either cos x or sin x. In the last lecture we have seen the right hand side is exponential. This is the goal for today's lecture. The number of sessions we have in the pipeline. For example, the right hand side is polynomial function, or the right hand side is the combination of blue and green color, which is exponential into polynomial, or the right hand side is the combination of blue and red color, which is exponential into trigonometric function. Today's lecture, the goal is right hand side is either cos x or sin x. So let us start with a particular example. We have given the differential equation y double dash plus 4y is equal to minus 2 sin x. This is the right hand side which contains the trigonometric function sine. Equation 1 is this equation y double dash plus 4y is equal to minus 2 sin x. We represent the equation in terms of d square y plus 4y is equal to minus 2 sin x. Now we know that to find the solution of this equation, we have to go for two cases. The first case is known as complementary solution, in which we consider the right hand side as 0, and another one is the particular integral. So for complementary solution, consider the right hand side is 0. So we have d square y plus 4y is equal to 0. So we have an auxiliary equation, d square plus 4 is equal to 0. So the factorization of d square plus 4 is d minus 2i and d plus 2i. So we have two values of d, 2i and minus 2i. I rewrite this as 0 plus or minus 2i. 0 is the real part and 2 is the imaginary part. So how do we write the complementary solution? The real part becomes the power of exponential. So it is e raised to 0x. That 2 will be in trigonometric function cos 2x plus sin 2x. Then we multiply by the number real constants c1 and c2. E raised to 0x is 1. So ycx is c1 cos 2x plus c2 sin 2x, where c1 and c2 are real constants. Now let us go for the particular integral. So to find the particular integral, we assume that ypx is equal to a cos x plus b sin x is the solution of equation 1. What is equation 1? This is the given equation y double dash plus 4y equal to minus 2 sin x. Now see, the question arises, why I assumed only this thing a cos x plus b sin x. We remind the last lecture also that for the assumption in particular integral, we concentrate on the right hand side. Right hand side, if it is exponential, then we assume exponential function. This is trigonometric function, so I assume the linear combination of trigonometric function. Now see, here we have given sine, but I am writing here cos and sine both. That is only because of the derivative of sine is cos and the derivative of cos is minus sine. So actually the derivative of cos or sine contains both the term cos and sine. That's why I am writing here the linear combination of cos and sine, which is a cos x plus b sin x. This is the solution of this differential equation. That means I have to substitute a cos x plus b sin x in place of y and its second derivative here to find the constants a and b. So let us find the second derivative of ypx. So the first derivative is minus a sin x plus b cos x, and the second derivative is minus a cos x minus b sin x. We substitute to the given equation. So y double dash minus a cos x minus b sin x plus 4 times y. What is y? A cos x plus b sin x equal to minus 2 sin x. So now let us combine the cos terms and sin terms. It is minus a cos x plus 4a cos x. The sin terms minus b sin x plus 4b sin x, which is equal to minus 2 sine x. The sum of first two terms is minus 3a cos x, and the sum of these two terms is plus 3b sine x. This is equal to minus 2 sine x plus 0 cos x. Now see, why I am writing 0 cos x here? Actually the right hand side is only minus 2 sine x. Here I have two functions, cos and sine. Right. So to compare the coefficients of cos and sine, I am rewriting the right hand side as 0 cos x minus 2 sine x. So after comparing the coefficients, minus 3 equal to 0 and 3b equal to minus 2. So a is 0 and b equal to minus 2 by 3, which we substitute here. So ypx is equal to 0 cos x plus minus 2 upon 3 sine x, which is minus 2 upon 3 sine x, and therefore the general solution is ycx plus ypx. So let us write ycx, c1 cos 2x plus c2 sin 2x, and ypx is minus 2 upon 3 sin x, where c1 and c2 are real constants. Okay, now in the last lecture we also discussed that there were another method to find ypx. So do we have that kind of method here for trigonometric functions or not? So ypx is this 1 upon f of d into rx. This is the another way how do we find ypx. So in the examination, either you can follow this method or this shortcut also. What is f of d? Is d square plus 4, and rx is the right hand side, which is minus 2 sine x. Okay, now this sine x, I am writing sine x as sine 1 into x, and I am concentrating on this one, right, one which is blinking here. Now see, where I am using this one, I am using one at this d square. How do I use this d square? Keep in mind, I am concentrating only on the term which is square, d square, right? So in place of d square, I write 1 square, this one whole square. So I am substituting d equal to 1 and whole square. Not only this, but extra minus sign also I substitute. This is the rule. In place of d square, I write minus of 1 square plus 4. This is the denominator, numerator is 1, multiplied by minus 2 sine x. So the quantity is 1 upon minus of 1 square plus 4 into minus 2 sine x, which becomes minus 2 upon 3 sine x. That you know, 1 upon minus 1 plus 4 is 3, and this minus 2 we have, which is same as minus 2 upon 3 sine x. Right. So in the examination, either you can follow this assumption method, which is known as undetermined coefficient method, or you can follow this shortcut. Now let us go for the next example. Third derivative of y minus 5 into second derivative of y plus 17 into first derivative of y minus 13y is equal to cos 2x. To solve this differential equation, so this is the equation number 2. What we do, we represent the equation in terms of d, so which is d cube y minus 5d square y plus 17dy minus 13y is equal to cos 2x. Now for complementary solution, we consider right hand side 0, so we have this equation, right hand side is 0. Once y is non-zero, we have this equation d cube minus 5d square plus 17d minus 13 is equal to 0. Okay, this is the cubic polynomial, and you know how do we factorize this? So the factors are d minus 1 into d square minus 4d plus 13 equal to 0. So one root we will get from this factor, and this is the quadratic polynomial. You know how do we find the roots? So the roots are d is equal to 1 and 2 plus or minus 3i. 1 is the real root and 2 plus or minus 3i are complex roots. So the real part is 2 and imaginary part is 3. Now how do we write the complementary solution ycx? See, this is one real number. So direct exponential function we have e raised to 1 into x. For complex, real part becomes the power of exponential, and 3 will be in cos or sine, right? So these two gives us e raised to 2x multiply by these 3. So we have cos 3x plus sine 3x. Clear? Again I repeat, this one e raised to 1x, this 2, so e raised to 2x cos 3x plus sine 3x. We multiply by the constants c1, here we multiply by the constant c2, and we multiply by the constant c3, where c1, c2 and c3 are real constants, right? Okay, now let us go for particular integral. So the same thing we have. We assume a cos 2x plus b sin 2x as the particular integral for this equation. Look at here, the right hand side is cos 2x. So I am writing the linear combination of cos 2x and sin 2x here, a cos 2x plus b sin 2x. What we do now? We find yp dash, yp double dash, and third derivative of yp, and we substitute to this equation. So the derivative is very much simple, so I am not wasting the time. This is yp dash, you can prove yp double dash and third derivative of y. You can verify the answer. Let us substitute here. So third derivative of y minus 5 second derivative of y plus 17 first derivative minus 13 into y, which gives me this thing 7a plus 26b cos 2x plus minus 26a plus 7b into sin x is equal to, what is this? Cos 2x, which has coefficient 1 plus 0 into sin 2x. Okay, the left hand side part is this. This is in homework how I am getting this. Now let us compare the coefficient of cos and sine. So the coefficient of cos is 7a plus 26b. Here it is 1. So the first equation is this. Coefficient of sine minus 26a plus 7b, and here it is 0. So another equation is this, minus 26a plus 7b equal to 0. Two equations and two variables. So we will get the unique solution of A and B. A is 7 upon 725 and B is 26 upon 725. I think this is not difficult, which we substitute here. So we have ypx is equal to 7 upon 725 cos 2x plus 26 upon 725 sin 2x. This is the ypx, and therefore we have the general solution ycx plus ypx, where c1, c2 and c3 are real constants. Okay, again, do we have any other shortcuts for this or not? This is ypx 1 upon fd into rx. Fd is d cube minus 5d square plus 7d minus 13. Right hand side is cos 2x. Okay, now I am interested in this 2. In the last example I was interested in this one, right? Here this is 2 we have. Okay, then how many terms which contains d square? This is the first term, minus 5d square, where we have d square, and this d cube also contains d square, right? This is not strange thing. How do we rewrite d cube? Is 1 upon d square into d, right? So it has d square minus 5d square plus 17d minus 13 into cos 2x. So we have two terms which contains d square. In place of d square, what we write 2 square with additional minus sign. So it is 2 square with additional minus sign into d minus 5. Again same thing, 2 square with additional minus sign plus 17t minus 30 into cos 2x. This is minus 4d and this is minus 4, right? So 17d minus 4d gives us 13d, and this is 20 minus 13 is 7. So we have 1 upon 13d plus 7 into cos 2x. Okay, now the question is, how do we deal with this d? Whenever we come to this situation, we convert this d into d square. So here I am explaining the logic. How do we convert this d into d square? And multiply and divide by 13d minus 7. Right, so let us divide by 13d minus 7 and multiply by it. Okay, so this is a plus b, a minus b, which is a square minus b square, which gives us 13 square, 169 d square, minus 7 square is 49, and this is the numerator. Yes, the good thing is d square. So in place of d square, what I can substitute? 2 square with additional minus sign, right, which is minus 4. So we have 169 into minus 4, minus 49 is this, minus 725. Okay, 13d minus 7 into cos 2x, which is, this is minus 1 upon 725, then 13d into cos 2x minus 7 into cos 2x. What is d? D is the operator. You can recall the first lecture in which we discussed some mathematical symbolism. What is d? D is nothing but derivative of cos 2x with respect to x. So let us differentiate cos 2x with respect to x. What is the derivative of cos 2x? Minus 2 sin 2x. Okay, and then we have final answer, ypx. 13 into minus 2 is 26 upon 725 into sin 2x, minus minus plus 7 upon 725 into cos 2x. This is the same ypx which we discussed with assumption method, right? Okay, we don't discuss any other examples for the trigonometric part. In the next lecture, we shall discuss when the right hand side is the polynomial.